Okay, John, we're live.
Doo-doo-doo.
Let me put on some music. So this is number 17th of our weekly chat. So 17. So how many months was that? How many months has it been?
If you divide by 4, it's like 4 and something.
Four and some.
About
Wow,
4 months, or
ti-
whether
time
yeah,
flies.
some months have 5. Yeah, yeah, time flies.
Time
4 months?
flies. 4 months.
Serious? Is it been 4 months?
Yeah, yeah,
Ah,
yeah, yeah. 4 months.
serious.
Four times four. 4 times 4, 16.
Yeah, but some months you have like 5 weekends or something like that.
True
Is
that.
that how it works? I think.
It's okay. Let's not think. Let's talk about what you
Like,
have.
what do I have? So last week I showed the game, rather I showed my earlier demos running on the actual GBA,
Mm-hmm.
the actual hardware, but the screen wasn't very good, so it's very hard to see stuff. So anyway, this week I got less distracted and I actually fulfilled my promise to show Tetris running on the GBA
Nice.
in the emulator for now. Yeah.
Nice.
I kind of tested it on the hardware too. It works. Just it's very hard to see.
Mm-hmm.
So yeah, I basically took my code that you saw, the Tetris code that I had earlier running on my Arduino on the 16:2 LCD. Most of the code was, the logic was pretty portable, and all I had to do was just rewrite the rendering portion of it.
Right. So you kept the
This
rendering
time,
portion very separate from the logic.
yeah, and that made it a lot easier to do things.
Nice.
So this time around, I'm using what is known as one of the tiled modes on the GBA. So basically, in tiled mode, you have a few backgrounds. So there are like 4 background layers on the GBA, and they are divided into tiles. And you basically it's basically a tile map lah.
Okay.
And the GBA also supports sprites that are tiled also, but I'm not using the sprites. So basically all I can do with the background mode is just paint squares, 8 by 8 squares on the background. So each of these gray color squares that you see is 8 by 8, including the border between them.
Each of these is 8 by 8. Got it.
Each of the gray tile, yeah, is 8 by 8, including the white space. The white space is on the top and on the left of the of the of the thing. So if you see, there's this here, over here, there's no gap between the. On the left side, you see a 1 pixel gap,
Yeah. On
and
the
on the
right
right
there's
side, you don't see a 1 pixel. Yeah,
got it. Got
because
it.
I defined like the border to be on the top and on the left.
Right.
Yeah. So if you look over, so the empty space is a bunch of tiles, a bunch of gray color tiles, a light gray tiles. The blocks themselves are dark gray tiles, and the background is black, is filled with black tiles. You can see over here in my code. So I defined like, so each tile takes up 1 byte. In one of the modes, I set it to use 1 byte per tile. There's a mode where you get 4 bits per tile,
Okay.
and then you need to change. There are certain
Sorry.
parameters you
So
need to
you
change.
say
Yeah.
one byte per tile, and it's used to represent the index, right? To what tile you want to use.
Yes.
So it supports up to 256 tiles.
Oh wait, no. Let me think.
Well, how many does
Oh
it
no,
actually
no,
support?
sorry. I made a mistake.
Oh.
What I meant to say is uh, so this is the tile definition. This is a definition for each tile, and it's 8 bits per pixel for a tile. Sorry,
8 bits.
made a mistake.
Got it. Got it.
8 bits per pixel for a tile. There's another mode that you can use where it's 4 bits per pixel for each tile, and then and it's like a 4 bits per pixel index into a palette, and then there are 16 different palettes to choose from.
Right.
That you set which palette to use in a different variable.
So all of these numbers, they are actually the color.
These are actually the palette index also. So it's 8 bits. It's an 8-bit index into one single palette. In the 4-bit per pixel mode, it's a 4-bit index into a palette, but you have 16 different palettes to choose from.
Ah.
Something like that.
So
Anyway.
you can in fact do palette animation with the tiles.
Yes, you can. You can do that too.
Nice.
Yeah.
Oh,
So
but
in this case,
how many, oh sorry. How many tiles does it actually support though? Like I'm just curious.
how many tiles? Right. So it uses 10 bits for the tile index. So that gives you 1024 tiles.
Oh.
In fact, let's take a quick look. You can see my palette over here. I have 3 different colors in my palette. I actually didn't even define the first one, but by default it's 0. My palette 1 is index 1 is this.
Wait, what
It's 84848.
what are we looking at
gray.
here? What's this palette window that you're showing?
It's from the emulator.
Wow.
This is the palette that I defined. So this emulator allows you to see the contents of the palette memory and all that.
That's
So
useful.
this is my palette. Yeah, my palette I defined the dark gray and the light gray in my palette, which in the code is over here. Excuse me, kinda. So you can see palette index 1 is this 16, 16, 16 light gray, dark gray color. Palette index 2 is 26, 26, 26 dark gray color. Let me just zoom in a bit.
Right.
Yeah. And then you can see my tile map, or my tiles. I'm using the 256 mode tiles. You can see these are the tiles. These are the 2 tiles that I defined. The original was a black tile. Index 1 is a light. My empty tile, if you go back here, it's an empty tile that uses index 2 for each pixel. Yeah. And then palette index. Oops, sorry. Yeah. And dark tile, block tile is index 2, which we can see here points mostly to palette index 1.
Right.
Mostly, yeah. And you can see how the endianness of the machine kind of affects things. This is little endian. The border is using palette index 2, but for some reason it has to be on the, because of the endianness, it has to be defined on the kind of, visually it looks like it's on the right side of the pixel. But represented in memory, these twos would end up in the first bit, first byte, or the earlier memory address, if you can call it that.
Right.
Yeah, and then this is how it looks like in the tile definition, and this is how the backgrounds look like. Ta-da! So the background is actually 256 by 256 pixels. And then there's this thing called an offset that you can use to kind of scroll the background around.
Okay.
But I didn't use the offsets. So, but anyway, yeah.
I don't have offsets as in.
Oh, so this I'm just using the backgrounds for this game. I'm not using like sprites or anything. I'm just like updating the background, the background tiles. So the background is actually 256 by 256 pixels. But as you know, the GBA screen is only 240 by 160 pixels. So why have such a big background canvas, right? 256 by 256, or you can go even bigger depending on the mode that you choose.
Right.
Yeah. So since the background is this big, the GBA hardware has 2 variables that allow you to define the offsets for which part of the background that you want to see. So if I did something like, hang on, let me do terrible things like define a global variable int x offset equals to 0, and if I did something like hang on, I don't remember what code I used. Let's see. Okay.
I'm just wondering where exactly does your Vim pull all of this autocomplete data from?
So I set up the thing to I set up a plugin. I used a plugin called You Complete Me, and it interacts. Yeah, the plugin name is called You Complete Me.
Okay.
Yeah,
Yeah.
and basically it interacts with a whole bunch of different compilers and interpreters to provide completion. So for C++, it uses Clang, the open source compiler,
Ah,
called Clang LLVM, whatever. Yeah.
I see.
You need to provide a bit of extra definition. There's this thing called compile commands that is automatically generated by CMake
Uh-huh.
if you specify a parameter, and it passes in uh, the what do you call it, the command to it shows the full command needed to compile a certain file. So like for main.cpp, this is the command that is used to compile this file, and then uCompleteMe basically takes this uh, compilation command and throws it into Clang, and then Clang uh, will attempt to compile a file in memory, and then it will provide the diagnostics back to you,
I see. I
something like
see.
that. Mm.
Private Orange in the chat says he's used You Complete Me before.
Oh, that's nice. It's useful, but sometimes it's a bit of a pain to set up.
Ah.
I spend like a long time trying to get you completely
Oh.
config to work
Well,
properly.
it's working now.
Yeah, it's kind of working now. Yeah, so what was I gonna do? All right, so I'm gonna try to compile this again, and let's see what happens. Hang on. Let's see what happens here. so, so
Whoa, whoa, whoa,
yeah, so
whoa, whoa,
if
whoa, whoa,
you
whoa. It does wrapping by
does it make
itself.
a yes, it does wrapping by itself.
Wow.
Interesting, yeah.
So that
This would
means scrolling background is kind of automatically supported.
yes,
Oh.
you can actually tell it whether to wrap or whether to what's the other mode? I think it's a clam, but I can't remember.
Oh.
Anyway, yeah. So this would probably make like for a very interesting Tetris gameplay kind of things. Like you
My
gotta
god.
remember.
My god. Do you feel like puking yet?
Close enough. uh, yeah, so that's that. So as you can see, actually, um, let's not do this.
Yeah, Private Orange says hardware accelerated scrolling.
Yeah, alright, accelerated scrolling. So yeah, no more puking.
Yeah, no more puking.
Yeah,
Yes.
so, but yeah, as you can see, I'm doing like something kind of big. Each tile is 8 by 8. It's not very. If I do 20 rows, right, I'm already taking the entire screen. So I probably want to find a different way of drawing the tiles, so that they don't like you can tell that the tetrominoes can probably be smaller, right?
Yeah, yeah,
Yeah.
yeah.
So I'll probably look into doing that for the next session.
Right. How much control do you have over I suppose there is no like camera, right? So if you want to, you have to code your own. Is it possible to zoom in and zoom out? Is it possible to I don't know, stretch any bitmap on the screen?
Right. So there is this affine transformation mode that certain graphical modes support. Then you can apply a affine transformation matrix onto the
A single sprite
thing.
or the whole
You can
thing?
do it on sprites. You can do it on the backgrounds also.
Wow.
So you can potentially do some sharing, some scaling, rotations as well.
And say for instance you are in game mode, right, and then you move on to a cutscene. It's possible to change the render mode, right?
Yes.
Ah.
In fact, you asked the last time whether it's possible to change render mode
While drawing, right?
mid.
Yeah.
Yeah, and I think it is entirely possible.
Ah.
Maybe that's something to attempt for next week.
That's cool. I've heard that for NES, right? The developers, because they have to they have to try to squeeze as much out of the hardware as possible, right? For
Mm.
performance. Sometimes
Mm.
they are only rendering to like 3/4 of the screen, right? And the background, right, is pretty much just static. You know what I mean? Like the background, like the horizon, right? Anything above the horizon would
Oh.
just be static, and then they are just drawing to what they are just refreshing whatever's below the horizon.
Yeah.
So so
Sounds good.
so they don't actually draw to the whole screen every frame. It's
Yeah, I guess that's one way of saving your cycles, CPU cycle.
so if you have like a UI portion on your screen, I
Mm.
suppose you can do the same, right?
Mm. Yeah,
Uh,
I think that's what the different backgrounds are for. So you can activate multiple backgrounds depending on the mode, graphical mode, and then you can draw like a static layer. You can update only that UI background once in a while or something like that.
oh, so you
I
can
guess.
think of different background as different viewports to draw to,
Yeah, different layers.
different layers. I see.
Uh, and you can transform the layers separately. I think. Let's see. I'm not sure which whether you can transform all the backgrounds. I think only backgrounds 1 and 0 support the affine transformation matrix. I have to go and read up some more. I
Oh,
haven't fully grasped everything.
right,
So
right.
this week was spent just grasping the whole tile mode, backgrounds,
Yeah, I
and
think
stuff.
it's super cool. Tile mode is what number? Mode what?
So 0, 1, and 2 are, I think, the. No, I've completely forgotten
Forgot.
already.
It's
I
fine.
think 0, 1, 2, 3 are the tile modes, and 4 and 5 are the bitmap modes.
So there are like a few tile modes and a few bitmap modes.
Mm. And depending on what features you want to activate. I think in mode 0 you get the affine transform matrix, affine transformation matrix,
Mm.
and some of the other tile modes don't support that. But you can activate more backgrounds.
But you're activating them
Yeah.
at a cost, right?
Mm.
I see. I see. I
Cost of
see.
memory. Yeah.
Cost of
Mm.
the memory. I see. You
Mm.
have we have a feature request. So
Oh.
Private Orange says you need glitch effects, chromatic aberration, bloom and motion blur. Looking forward to seeing all these effects, John. You gonna code
I,
them in?
I will try. I will try chromatic aberration. Let's do that.
I mean, like way back in school, right?
Mm.
You have done software side the pixel manipulation, right, on
Oh
Flash.
yeah, yeah.
So
Mm.
imagine you can do the same thing here,
Let's
right?
let's give
We
one
just
more
don't know.
try.
Yeah, we just don't know whether the GBA will crash and burn.
On the emulator, it will probably work fine.
On the emulator,
There are a
but
lot.
you have an actual GBA.
Yeah, we'll
Yeah.
see if it catches flames. If you don't hear from me next week, if you don't hear from me next week, it's probably because the whole thing caught fire and burned down my home.
Cool, man. This is cool. This is fun. This is awesome.
Mm. Okay, goal for next week. Chromatic aberration on the on this
Serious?
Tetris
Wait, you're
game.
serious?
I will try. I don't know if I can succeed, but I will try.
Chromatic aberration.
Yeah,
Chromatic aberration would be a separation of the color channels, right?
yeah.
Is it just that? It's just that, right?
I think so. I
Okay.
think so. I sure hope so because that's what's in my head right
Okay, yeah, that's cool. I don't
now.
even know how you're going to do it in top mode, man.
I have no idea too.
That's fun.
Mm-hmm.
So,
Mm-hmm.
wait. So next week, literally, chromatic aberration,
Yeah. Let's try. Small steps, baby steps.
baby steps, baby steps. Doing
That's the baby step, but
shader stuff in in GBA. Oh man. Okay. Looking forward to it. It doesn't feel like baby steps, but yeah, sure. If you say so,
no,
right?
I couldn't.
Okay.
It for me.
Sorry.
Your turn.
John, you're getting cut off. Can you repeat what you just said?
Oh,
Yeah.
yeah. That's it from me.
That's it
Your
from
turn.
you. Okay.
Mm.
Okay. Just one moment, John. Let me prepare.
Mm.
Let me prepare. How do I'll just stop watching your screen, right?
Mm.
Okay, and then I'm going to share my screen with you. So again, mine has nothing. Mine has like nothing to do with hardware. It's just talking about my game. So share my screen. Which screen is it? Screen 2. Can you see my screen?
Awesome. I can see it.
So I did a few small things, like including making another level. But I think I want to just focus this week's presentation on one thing. Let me show you this. So remember last week I was showing you like the portal graphics, right? And I said that I want to render the portal horizontally as well. So yeah, I've done that, but there's nothing.
Oh.
It's not like it's not interesting to talk about, right? It's just some small changes to already existing code. But what I would like to show instead would be this. Are you able to see the difference in the color? Is the contrast big enough?
Yeah.
Okay, good.
I can see the.
Let me go to this. So yeah. So the thing is, I've been feeling a little bit troubled, right, by how flat the game looks. So I've been trying out like a few different things to make the visuals pop a bit. So the first thing that I did was I tried to make like small little doodads, right, as decorations for the environment. So the grass, which I've shown you, right, and I wanted to make stuff like the portal looks a bit better. And now I'm finally at this stage where I'm thinking of playing around with lighting and shadows. So so this is what I have at the moment, and the goal, right, is to attach this to the player. So that's step one, right? Attach it to a player, which I've already done, but it's not in this demo. And after that part is done, I want to be able to support multiple light sources. So in other words, it means that all of these lights, right, they are supposed to be able to merge, kind of like a meta ball effect, which is the tricky one. At that part, I have not done yet. But let's do some visualization. So as you can see, right, these are the points that is generated in order for me to draw my triangle street. So essentially, what I'm doing, right, let me see if I can bring out paint. So I'm just going to talk about my process. Yeah. So I've not actually done this before. So it was fun. It was fun to work on, right? It's fun to think about how to do something like this. And I think most of the online examples, right? I think basically they are just casting. The shadow just extends forever until the end of the screen, right? In my case, I kind of want it to end at the edge of the circle. So then I have a circle here, right? And then I have the center of the circle. So the first thing I did is I just draw on my notebook, right? I just started drawing on my notebook and see if I can make sense of the thing. And then this is, say this is a towel, right? Then the goal is to be able to do this. And be able to determine which part of the circle, right, is in shadow. So the first step is I just render the circle as a whole, which is fine, right? Rendering the circle is easy. Then afterwards I have to figure out which part of the circle I have to cover up. So then the first step is I look at this diagram and I'm wondering, how do I determine these 2 points? Yeah, that was the first question, right? And I figured if I take a displacement vector, right, from the center of the circle, right, basically the source to the light source to the center of the tau, then I can then compute the normal, right? And with that, right, if I were to just do a dot product, right, of all the 4 displacement vectors, like this one and this one and this one and this one, so these are the 4 displacement vectors. If I were to do a dot product of all 4 displacement vectors against my normal, then essentially I will be able to find the 2 extremities. So I call them extremities because I don't know what else to call them. So I will be able to determine the projected distance, and the 2 with the longest projected distance on either direction, right, will be the extremities. So then I have this and this, right? I call them the extremities for the lack of a better term. Okay. Yeah. So once I have that, I can then kind of extrapolate this particular vector, if that's the right word, and find the point on the circle. Would that make sense? That would, right? In fact, I mean, I can just determine what the angle is, right, of this particular displacement vector, and then from there I can find this point. So in GameMaker there's a length direction, which helps you to calculate the displacement vector. So essentially you just need to pass in the angle of the vector and the length, right? But essentially what GameMaker helps us do, right, is just helping us call cosine and sine, right? So okay, that means I have my 4 points. Then the thing is, how do I cover up this arc? Because that's the tricky part, right? It's an arc. So how do I cover up this arc? Oh, well then I figured if I have a start angle, right? Start angle and an end angle, right? Or in fact in code I call it min and max. Then essentially I can just kind of interpolate incrementally, right? And then figure out the intermediate points, like so, right? So I can just be like, oh, you know, I move like maybe an x angle in this direction towards the n angle, and then I move again and I move again, and so on and so forth. Yeah. So I have all this 1, 2, 3, 4, 5, and then that's just for the points on the circumference. The next part is I need to actually have corresponding points along this line. But that is okay, right? That's generally not hard, because so long as I know how many segments I have, I can just linearly interpolate and get all of the corresponding points. That makes sense? Yeah.
Okay.
And then once I have all these points, right, it's pushed into a list in this order: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then I have my triangle street, which is what's happening here.
Okay.
And essentially that is the algorithm. But then so this is where I'm at the moment. I kind of want to do more with it. So one of the things that I'm a little bit stuck at, right, is how do I merge 2 lights together? That means, you see, so this is beyond what I've done already, right? So this is the stuff that I'm still actively working on. But imagine we have this part that is supposed to be in shadow, right? This part. But then what if I have another light source here? Then what's going to happen is only this part will be in the shadow. Yeah, and this is going to be a little bit tricky. What I'm thinking of now, right, is I'm going to render this entire shape, right? into separate surfaces, and then I kind of try to work it out. Basically, I have to do multiple passes now, right? Like I am going to have individual render targets for each light, and then then I'm going to have to figure out a way to combine all of these render targets. Yeah. So that's the tricky part. And I don't want it to just be a solid color. So what's going to happen is I'm going to render. I'm going to have a gradient. So it will start off as a solid color in the center of the light source, and then here it will start to fade out, right? And that means how do I put it? It will start to fade out, but that means that if I have another light source, right, the two faded out areas can combine to form a more solid shade, right? And then if I were to apply a quantization pass, if that's the right term, I can then kind of have a metaball effect where the light merges like that smoothly. You know what I mean?
Yeah.
Yeah, because if I don't have that step, right, if I don't use a gradient, then it's going to be very solid, right? It's going to be like pointy, right? It's going to be very pointy where it intersects. But I kind of want it to be smooth. So that's the goal. But if I am not able to achieve this, then I'm like, you know what? Maybe it's not that important for a small platformer. Yeah. But I kind of have this working in Project Dungeon already. You have seen it, right? Yeah. But now the trick is to make it work with all of this occlusion going on.
Right.
Yeah. Yeah. Oh hey, thanks Private Orange, and Wei Liang is here. Wei Liang says Shiniken's 50 Shades of Grey. I'm not quite sure what he meant. Okay. Yeah.
Gradients.
Right. Yeah. The gradients. That's right. Actually, can I show you like another version? So I have one artifact that I did not fix. Let's take a look. Let me run this build. So I have a graphical artifact. Not nice. But I don't know if I should fix it.
Whoa.
Yeah, I changed it to red to be able to see like any discrepancy in the rendering. So look at this. This is fine, right? This seems fine. Now look what happens if I look towards the bottom right of the circle.
Bottom right of the circle.
Okay, now do you see a graphical artifact?
Oh, a bit of a red there.
That is outside of the circle, right?
Yeah.
That happens when the so-called outer points, right, is closer to the center than the inner points. Which can happen, right? Let me see if I can render. Let me see if I can illustrate it. How was it? It was like that, right? So basically, I identify these two as extremities, and then let's see. Yeah, and then this is and this is the inner. This is the points on the circle, and this is the extremities. So I have to reject this particular case because, as you can see, right, it will start rendering this right, which is exactly what's happened. Yeah, I was just wondering, do I need to actually reject it if no one can see it anyway?
Yeah. If you can't see it, it's fine, right?
Yeah, I mean, how expensive is it to create another triangle, two triangles? I don't know. If it's too expensive, then I'll reject it. But if it's not lagging, then I'm not going to care, I think.
Yeah.
Private Orange says now you can have rogue levels. Rogue levels? Rogue levels. Oh, like those roguelike games where the shadow will kind of obscure where you're going? Maybe. I'm not sure. Keeping it simple first. Okay. Yeah, and essentially that's it, John. So I've shown you what I currently have, and I've talked about what my plans are with regards to multiple light sources. So I will try this. If it proves to be too much effort, I might actually just drop it and move on to making levels. So I've actually made like a new level with Private Orange's help actually. maybe I'll show you next time, right? Maybe I'll show you next time. I think if I show you every single level, then I cannot get you to playtest.
Yeah.
Yeah. So let me think. Is that it? Yes, that's
I'm
it.
just wondering.
Mhm.
I'm just wondering if there is if there is any problem with you want multiple light sources. I wonder if just drawing them one after another, whether that will. So you draw the first circle and then you draw the shadow. Then you draw the second circle. Then you draw its shadow. Whether that will cause any issues with the shadowing.
Yeah. The shadow will end up blocking whatever's drawn first, right?
Will end up blocking. Okay.
Right. We'll end up
that's true.
blocking other light sources, which may not be what we
Right.
want, right? So, which
Right.
is why I'm now considering rendering every single light source in its own render target, and then instead of having all of the shadow, right, the red stuff as a solid color, I'm going to do some kind of a additional pass, right, to turn them transparent instead. Does it make sense? That's the goal, at least. Yeah, but it does feel like I'm having like multiple passes, and considering I want this to run on the mobile, I'm not sure what the impact will be. But I guess I'm but what is true, right, is that I'm keeping the render target very small, which basically the entirety of the level, right, which informs the size of the render target, is just 180 320, which I think is pretty small, right? So hopefully it works okay on a mobile device. So yeah, at the moment I'm just looking at this. Woo!
Cool.
Yeah. If you notice, right, the shadow polygons, they are actually protruding out of the circle. Yeah, I had to do that. Otherwise, sometimes, right, you see a little bit of artifact on the
light.
on the circumference.
Yeah.
Yeah. You see like, hey, what's this 1 pixel thingy? So I have to make them protrude outwards.
Right.
Yeah. That's it. That's all I have.
It kind of looks like those security guards and their torchlights.
Oh, it does, huh? It does. Yeah, it does. I just find this really fun to work on. I think some amount of linear algebra is always fun to work with, right? And trigonometry, I think. Yeah, this is always fun. Woo. Yeah, that's it. I already talked about what I want to work on next week, right? Yeah. Then let's recap. You said you want to work on.
I'll work on trying to implement chromatic aberration on the Tetris thing.
Can we have a video capture next week of the actual thing on the actual device?
Yeah.
Is
sure.
it possible? It's possible, right?
If I can find a separate torchlight or something.
A separate torchlight.
Yeah,
because
I need a light.
because it's barely visible, right?
Yeah, it's barely visible.
Barely visible. The screen of the GBA is so terrible. Yeah. But okay. And for me, I'm going to keep working on the light sources. I want to have multiple light sources. Okay. Shall we call it?
Yes.
Yeah. Today is a short one, but I think today is an interesting one as well.
Yeah.
Okay.
Yeah.
Okay. Thanks everyone for hanging out. We are going to continue our discussion next Sunday, same timing. Oh, hang on.
Same
Private
time,
Orange
same
has
thing.
something to say. I think Metaball lights could work, but yeah, performance would be good to test on mobile. True. Maybe it's possible to sum the light contribution to a shared texture or something. Yeah, I'm gonna try that. I'm going to render all of the light onto a final render target, and then I will just do the post-processing needed on it, right? Like quantization and stuff like that. Yeah, we're going to see how that works out. Cool, man.
Myself, I would just choose full screen shader, all the things.
Yeah, but you know, right? Have I told you in Serious Scramblers, when I do the full screen shader, like basically when you die in Serious Scramblers, the game turns black and white, right? So on the iPad Mini, the frame rate just drops by half. It goes from like 60 FPS to 30. It was crazy. I don't I don't know why a small little post-processing shader would kill the frame rate like that. Yeah. Or maybe my render target is a bit too big, so I have to look into that.
Maybe.
Maybe. Okay, thanks everyone for hanging out. Thank you so much. We'll continue our discussion next Sunday, same timing. Okay. Anything to add, John?
Bye bye.
Bye bye. Bye bye. See y'all. Thank you.